plus then square root of 3x over square root of a plus 2x plus square root of 3x. Then the conjugate of this guy too, we'll write it. So that will be x square root of, like you don't understand, you can come back. So when we want to expand this is just like difference of two squares. So we can just square both of these sides. Then we'll have a plus 2x minus 3x over, the same thing goes for this guy and this guy. So this will be 3a plus x minus 2, sorry, no. This one will be 4x. Thank you. 4x. Then multiplied by root 3a plus 2 root x over this one. So this will be square root of a plus 2x plus root 3x. So this is what we have. You don't understand? Okay. You get this part? Let's say this is a new question now. How would we rationalize this? Multiply by the conjugate, Shebi. So that will be root of a plus 2x plus root of 3x divided by this same thing again. A plus 2x plus root of 3x. This is how we rationalize normally, Shebi. So now, in this case, okay, let's say this is 1. Let's say this is 1. Then all this means is you can write this as 1 over square root of 3a plus x minus 2 root x. If you want to rationalize this one again, you do the same thing that we did for this one. The conjugate, you are multiplying by the conjugate. You multiply the denominator and the numerator by the conjugate. So that means instead of now like splitting it into 2, they just combined it into 1. So the conjugate of the first one, multiply it by this. Then the conjugate of this one, which is this, multiply both denominator and numerator. Do you get? Okay. Let's say this is only what we have. This is the question. They say rationalize this. They say rationalize this. How will you rationalize it? You multiply by the conjugate. You multiply the denominator and the numerator by the conjugate. So now, what that means is that you can this over 1, but this is the conjugate. You are multiplying both the denominator and the numerator. But in this case, the denominator is not 1. The denominator is this, and this can also be written as how. You can write this entire stuff. This root a plus 2x minus root 3x over square root of 3a plus x minus 2 root x. You can write this question. You can write it as root a plus 2x minus root 3x over 1 times 1 over root 3a plus x minus 2 root x. Do you get this part? So now, so what they are just saying is get the conjugate of this one. And when you do the conjugate, what do? You multiply both the numerator and the denominator by it. So now this conjugate, we'll multiply it by this one. If we're solving it like just if this was one question and this was another question, if these were two different questions, how will you do it? Just the same way. But because of the multiplication sign, we're going to multiply everything together. Do you get it? If you don't get, I can come again.
The first one is the conjugate as the and the second step is multiply the conjugate of the one below.
Make your work easier. For this one now, for this kind of question now, basically all you need to do is square this guy. Square this guy. Okay, let's say this is the question now. We've not added the limits, but let's say you are rationalizing this. So if they tell you to rationalize this now, basically what you need to do is, if you don't want to do this expansion method that will take time, you can just square this, your numerator. When you square it, all you have if you square this guy, this goes off, maybe. So that will be a plus 2x. Square this guy too. That will be minus 3x. That's what we have here. It's just the same thing. So instead of stressing yourself, then over the same thing for this one, square this guy. This goes off. You are left with 3a plus x. Then if you square this, this is 2 root x times 2 root x. 2 times 2 is 4. This will be x squared times 1 over 2. So it cancels out, so we'll be having 4x. And this is the 4x here, minus 4x. This is what we have here. Just the same thing. Just square your question. Then the next step is then you now multiply. You multiply. Know that this denominator now. This denominator. The question is what? The question is a plus 2x minus this expression. Now for the numerator, in the numerator case, just multiply the conjugate of the denominator. What I mean is, this is the question. So now we've done this first step of squaring your question. Just square your question and write it back. So now the next step is, for this numerator now, for this place, the conjugate of your denominator, which is this is the denominator, right? So this is the denominator, square root of 3a plus x minus 2 root x. What's the conjugate of this guy? Yes, plus 2 root x. So now what I said earlier was, you multiply by the conjugate of the denominator. So you just whatever the conjugate of this guy is, you write it at the top. So what we have here is square root of 3a plus 2x plus 2 root x. 4x. Yes, 3a plus x. I don't. Okay, sorry. 3 plus x, which is what is remaining here. Then the conjugate of this one, the conjugate of your question, so that will be square root of a plus 2x plus square root of 3x. So instead of going through this guy, if you don't understand it, you can just use this method. Square your question, the entire question, square it, then multiply by the conjugate of the lower one. You get? Do you understand? You don't understand? How did you solve your multiply by the conjugate? Basically, that's just it. So if you don't understand this log process, you can just use this. Square your question, then multiply by the conjugate. So by doing that, you've skipped this long line, then you've gotten to this place. If you don't get, I can just come again. So the question was the limit of x approaching a, right? Are you done, right? I'm talking to. Yeah. Okay. So now, from here, a plus minus 3x plus 2x, that's minus x, right? Over 3a minus 3x. Then multiply by this guy, 3a plus x plus 2 root x all over root a plus x plus square root of 3x. So now, do we get to this place? Just addition. 3 minus 3 plus 2. That's minus 1. Yes. So now, from here, I can factor out 3 to get this guy. So from here, I'll be having a minus x over 3 into bracket a minus x times square root of 3a plus x plus 2 x over root of a plus 2x plus square root of 3x. So this can go, right? So I'll have 1 over 3 times, then the limit can now come in. Limit of x approaching it. That means wherever I see x, I'm meant to put a. So from here, I'll have 3a plus a plus 2 root a over square root of a plus 2a plus 3a. So from here, I have 1 over 3 times, this is 4a, that's square root of 4, that's 2 root a plus 2 root a.
So this is our final answer.
Nope, you can rationalize.
Oh, I mean the A.
Okay. Yes, the a can come up. So this would be so this would 2 plus 2 is 4 now. Yes. It's 2 root a. You get? Okay. You guys get? Okay. So this one is just the assignment. I'm coming. Okay, let's take one more question on this guy. Can I rub off the board?
Yes, sir.
Everybody? Okay. While they are still writing, you guys can check out this one. Evaluate the limit of x approaching 1 of x squared plus 8 minus square root of 10 minus x squared over square root of x squared plus 3 minus square root of 5 minus x squared. What's the first thing we're going to do? What of direct sub? Sometimes your answer might be there. Yes. In like very rare case. But if we will never do that.
But you want to factorize it.
No, sir.
Let's do the first fraction.
Infinity.
I'm not being a sick. Would you get myself? Give myself.
We did not finish Did we finish what we did not finish what we were doing last week and the last class, right?
No, we finished it. That was the assignment to do.
No, like before we did direct sub, we did factorization, round rationalization, then standard result method, yes. So we'll do standard result method, then we'll go to where they can ask questions, go.
Everything is how to treat it.
You guys have to learn how to be fast too. As the class goes on, we'll do this stuff that's been passed down from yes from them. I don't know who passed it down to them Kenneth, but them Kenneth passed down to us. It's something we used to do during jam class and wire class. You write a question, 30 seconds to solve it, sometimes with pen, sometimes without pen. You solve, then you say your answer, then you solve it. Then you collect a good score. Okay. Philip, you solved it, Abby. Solving, I know you solved it. I've seen it. What did you get? Talk now. Oh yeah. This one should be simple for you guys now.
Advan. So, sorry, answer.
What did you get? I'm not solved it. 2/3. So we have 2/3. Do you have any other answer apart from this? Yeah, I know. I'm just saying. But yeah, what did you get now? Is it different from 2/3? Okay.
Oh, yes.
Great. And press, right? Press. Okay. Shannon. You guys are done writing with. So 1 more minute and you start solving. All right, let's look at it together. So when you use direct sub, what do you get?
We got 0/7.
So this is 9. This is 3. 9. This is 4. That's 2. 4. That's 2. So that's 0/0. Right. Great. So now how do we solve this? Factorization might not work here unless it was x to like infinity. Then I hope we get there today. If you are fast. Okay. So now rationalize. How do we rationalize? Square your question. Both the denominator and the numerator. So for the numerator, what do we have when we square it? X plus 8 minus 10 plus x squared. Do you understand this? Do you understand? You understand, Abi? Okay. Great. Do you understand? Yes. Then square the denominator. When we square the denominator, what do we have? We have x squared minus plus x plus 3 minus 5 minus or plus? This the minus will affect it now. So it will be minus 5, don't forget, plus x squared. So now, this is not meant to be squared. Okay. I'll skip. You get this squared? Like here. It's squared in your question? Yes. Okay. Alright, great. So this is meant to be squared. So this will be 2x squared minus 2 over, what do we have here? 2x squared, same thing, minus 2. Multiplied by, now, the tricky part, multiply for the numerator, for this side. We are going to multiply by the conjugate of the denominator. So for the numerator, multiply by the conjugate of the original question, the denominator. So that will be what? That will be square root of x squared plus 3 plus square root of 5 minus x squared. Then for the denominator, you pick the conjugate of your numerator. That will be square root of x squared plus 8 plus square root of 10 minus x squared. So now this can go. We agree, right? This can cancel out. They're the same thing. So that will be square root of this, and it is limit of what? Of x approaching 1 of square root of x squared plus 3 over square root of x squared plus 8 plus square root of 5 minus x squared, square root of 10 minus x squared. Great. So now plug in 1 wherever I see x. So this would be square root of 1 squared plus 3 plus square root of 5 minus 1 squared over square root of 1 plus 8 plus square root, is it plus or minus? Yeah, plus square root of 10 minus 1. So this will give me 4. Square root of 4 is 2. Square root of 4 here is 2. Then 9. Square root of 9 is 3. Square root of 9 is 3. So this will be 4 over 6, which is 2 over 3. Sharp. Do you guys understand? You seen the oh yes, the sign is must affect it. I said it in the last class. Okay. Now let's go to that. Okay, let's go to standard result method. This another. So we've taught them. We've taught direct substitution and rationalization now. So now we are going to standard result method. This is another way of solving limits. Okay, so standard result method is basically dealing with indices. You must be familiar with indices a little bit. So now, standard result method. So it's basically when you have raised to power of something that you use this standard result method. So hold on. Okay, now this is the formula. Limit of x approaching a. When you have a limit like this, your question will always be x and a. It can be values and it can be variables, but this will be numbers, and in some cases it might be letters too. We have to use your to solve it. So now the formula you just use here is called nanny. I like to call it nanny, but it is nanny like the guy that plays football, so I can remember. So now it's just n the power multiplied by a this guy times n minus 1. So this is the formula. Solve it. So now it might not really look familiar, but let's check this question. Example. Limit of x approaching 2 of x raised to power 5 minus 32 over x raised to power 2. We should be able to solve this now. You must take note of something. The x and a, they must be equal. They must be the same thing for both the numerator and the denominator before you can use this formula for it. This is the formula. x minus x raised to power 5 minus 32. Eh? What do you get? 80. All right. So somebody got 80. Is there any other answer? Okay, is there any other answer? Did you get 80? You got 80, sharp. So now, let's see how they got 80. You just want simple formula. We have to break it down. They must look alike before you can use this formula. So how do I break this down? Limit of x approaching 2. This guy now, know that this is in the format of x raised to power n minus a raised to power n. I need to get this x raised to power 5 minus 32. I need to get it in this format so I can use this formula. So now, 32, I can write 32 in terms of 2 now. That's 3 raised to power 5. So instead of 32 here, I have 3 raised to power 5 over x raised to power 2. Sorry, over x minus 2. You get it, right? So now the formula is now what? N a raised to power n minus 1. In this case, what's my n? My n is 5 now. If the power is n, so that will be 5. What's a? A is 2. 3 raised to power 5 minus 1, that's 4 now. So that will be 5 times what? 5 times 16. 5 times 16, that's what? That's 80. Do you understand? What's n? N is 5 in this case. N is 5. And a is what? A is 2. The formula is n. What's n? N is 5 into bracket. A, what's a? This one is into bracket. So don't like. What's a? A is 2. What is n? N is 5 now. 5 minus 1. So this will be 5 times 2 raised to power 4. So you get? That will be 80. You understand? So you get? Just the formula. Just so let's check another question. So limit of x approaching 3 of x raised to power 5 minus 243 over x minus 27. So we have 2 minutes more. Philip, have you gotten it? Has anyone tried it? Philip, what did you get? It's not up. After the assignment part. Is it working on your phone? Eh? 405. Great. 405. Do you have any other answer? What did you get?
Inspiration just came out of
405. Sure. So we have another 405. We got 405 tab. And let's solve it now. Let's see it's 405. Okay, now let's check this question now. Okay, we have limit of x approaching 3. The clue to the question, the clue to solving the question is already in the question. We know that what they are trying to do is we need to get something about 3, because 3 can go with this guy and 3 can go with this guy. But now the problem there is, how do I get it in this format? So now, before we get to this place, we know that 8 over 64 is what? Is 1 over 2. 1 over 8, sorry. So now 1 over 8. So now I can write this in another way, and I'm not changing the question. 8 over 1 times 1 over 64. Is it the same thing? If I multiply both sides by, if I multiply this one and this one by 1 over 8, did I change? Wait, hold up. Did I change the question? I didn't change the question, right? You see the same thing, right? Okay, now, basically, this will cancel, then I'll have my 1 over 8. That's the concept we are going to use in this one now. For this one now, I have 8 raised to power and x raised to power 5 minus 2 raised to power over x raised to power x minus 27. Right? Come. Should this have cube? Nope. Okay, let's go. So now, if I multiply, this can, just the way we did that 8 over 64 stuff, x is power 5 minus 243. If I now divide this by x minus 3 times x minus, okay, x minus 3 over x minus 27. I didn't change the question, right? Yeah. Okay, great. So now I can write this guy. I can write this guy as 3 raised to power, what is that? 3 raised to power 5, right? Okay. So this will be x raised to power. Hold up. This one is meant to be 1 over. Do you get? You know that it was division operation that was between them before, and I changed it to multiplication. And you know that if you have like 1 over the reciprocal of whatever you had before, do you understand why I did?
Now, if it's at that point, you have over, you can get the same.
But we've changed the question, that's what I'm saying.
I'm saying that if you do not add 1 over,
Okay.
you can be like, if you look at like x minus 3 cancel x minus 3, you still get back to the question. So I don't think they need to add 1 over.
Great. That's great.
If you add 1 over there, the question will change. It's not that question, but as it is now.
Oh yes, that's correct. There's no need for the reciprocal. There's no need for the reciprocal. When they eventually cancel out, this is coming to this. You get. So this will be x raised to power 5. Over x minus 3. Now we can use the formula here, right?
Yes, sir, yes.
We can use the formula for this one. So in this case, n is what? N is 5. A is 3. Should so that will be what? And the formula is na is to power n minus 1. So that will be 5 into brackets. So now, how can we do this? So now, how can we do this? I can rewrite this. If I write this guy as this 405, because this is not in the format of this guy 3 cube over x raised to power minus 3. Did I change the question? I did not change the question, right? Do you understand? Do you understand what I did? You don't understand? Okay. What I did was, I'm having like 8 times 32 over 64. If I rewrite this guy, if I write this thing as 8 divided by 64 divided by 32, I did not change the question. I just use what's the name now? Yes, multiplication and division, their relationship. Because this can also be written as 8 divided by 64 over 32. If I change the division to multiplication, it will go back to 8 times 32 over 64. So I did not change the question at all. So now, since I've not changed the question, so now from here I can use the formula of that of this standard result method. So if I use the formula, I'll have 405 over, this will be NaN. So this will be N. What's my N in this case? My N is 3, right? I think this is meant to have cube. Let me check the question. Okay, sorry, my bad. This is meant to have cube. Sorry. Yes, this is meant to have cube. I'll try looking at it that it's not looking like. So this will be my n is 3 in this case. And what's my a? My a is also 3. 3 is to the power 3 minus 1. So this will be 405 over this will be 9, I guess. 9 times 3, that's 27. So 27 divided by 405, what do we have? Do we have just one number? 15. So all of you that chose 405, where did you get 405? You guys grabbed this other side. So you guys have seen the mistake now. Do you understand? There's meant to be cube here. Yes, there was a mistake in the question. It's meant to be cube here. Do you grab? If you don't get, I can come again. Do you understand? I should come again. Wait. Eh? This way there's meant to be cube. Oh. This way there's meant to be cube. You understand? I added x minus 3 to this guy. I did not change the question. This is what I did. X raised to the power 5 minus 2. If I multiply these two guys together, I'll go back to this. So now instead of putting 1, because I want to make my question look like this, look in this format, so I can use this formula. So now, how can I write it? They've given me a clue. Everything deals with 27. I can write it in multiple of 3. That's 3 raised to the power 3. This one, so I can write it in multiple of 3. 3 raised to the power 5. So now, what can I add at the denominator and this guy, at these places? That will not change the question, but it will make my answer look like this. Let me write this in. X raised to the power 5 minus 3 raised to the power 5 over 1 times 1 over x raised to the power 3 minus 3 raised to the power 3. This is still the question, JB. Yes, sir. So now, it is remaining one more thing for me to be able to use the formula. And what is it? I can write x minus 3. So that once I add x minus 3 at this denominator, once this changes from 1 to x minus 3, I can use this formula because it already resembles it. In this case, x is x, a is 3, and n is 5. N is 5. So I can use the formula for this first one. So for this guy too, so that I will not change the question. What I added to this guy, I must add it to this guy too, so that the question remains balanced. So I will now add x minus 3 here also. So you get. So now I've not changed the question because this will cancel this and this will go back to the original question. So you get. I did not change anything now. So now for this one, I can use the formula. And when you use the formula, this is what you get, 4, 5. And then that's the 4, 5 that you said. But now, since this one is looking inverted, this is the formula. X raised to the power n minus a raised to the power n over x minus a. So for this one now, x minus a is meant to be at the denominator. In this place, x minus a is at the top. It's meant to be here. So that's why I inverse it and I use 1 over. So that's how I got this. Should I solve the part again? You already understand? Sure. You guys understand, right? You understand? So let's check this question together. You guys will first check it then. So should I rub off the board or you've written it? Okay. So we have limit. The limit of x approaching a of x root x minus a root a over x minus a. So 1 minute, guys.
So x minus a over x.
Just indices. This one tests how well you understand indices.
The answer is 70. So I think it will be what? I'm not sure.
Okay, we have one answer. 3 root 8 over 2. Do you have any other answer apart from this? Oh, sorry. This is the question. Do you know where to put on the bulb? Limit of x approaching a of x raised by n minus s. So your question must look like this before you can use this formula straight. Because when you get to school, you might not see this. I'm not sure if this is inside to teach you this. You might just be looking for a way to do it, but there's just a single formula to solve it. Just use that nanny. But before you can use nanny, it looks like this. Basically, that's just it. So now how do you make this guy? This one already looks like this, exactly the same thing. But how will I make this one to be powered? To look like this, to be exponential. How do I make this to be exponential? That's just what you get. 3 root a over 2. Is your question 3 over 2? What do you get? You don't get it. Pray, did you get it? Okay. Alpha guy. What's your name? Gideon. All right. Just some indices rules, and once you get that first step, the rest you can do it with your head. Should we solve it together? All right, let's solve it together. So now, like I was saying before, we need to make the question look like this. This denominator, we don't have any issue with it. So the denominator stays the same, x minus a. You understand, right? So now for this guy now, let's write it here. X raised to power, x root x. So now this x, I can leave it like this. This root x, you know that root is the same thing as 1 over 2 should be just the power. So this should be x raised to power 1 over 2. X raised to power 1 is still x now, Chibi. So now, if we use that indices law that says a raised to power m times a raised to power n is the same thing as a raised to power what? M plus n. You understand this guy? So now, that means I can write this guy as x raised to power 1 plus 1 over 2. Shebi, 1 over 2 can be written, one can be written as what? 2 over 2, Shebi. Instead of doing LCM and the likes, it should be x raised to power 3 over 2. Instead of doing LCM, I can write 1 as 2 over 2 now. So that's 3 over 2. That means this x raised to x root x is the same thing as what? X raised to power 3 over 2. Shall we get? You understand, Abi? So in this place, I can write x raised to power 3 over 2. So basically, this one is just the same thing. A raised to power 1 times a raised to power 1 over 2, which is equal to what? A raised to power 2 over 2 plus 1 over 2. A will be equal to what? 3 over 2. So that would be minus a raised to power 3 over 2. Now from here, I can just use the formula directly. And what is n? My n is this, in this case is what? 3 over 2. The formula I'm using is n raised to power a raised to power n minus 1. N multiplied by a raised to power n minus 1. So this will be 3 over 2, because my n in this case is what? My n in this case is 3 over 2. So that will be 3 over 2 into the bracket of, what's my a? My a is a in this case. Multiplied by, then what's my n? My n is 3 over 2, right? 3 over 2 minus 1. This will be what? 3 over 2 into bracket a multiplied by 3 over 2 minus 1 is what? That's 1 over 2, right? So that would be 3 over 2 root a. You guys understand? So the complicated part there was, how will I write this to look like this? Once this guy looks like this, you can solve the remaining with a decent and you understand? Can I rub up the board? Okay, let's check this one. Limit of, first time please, you are beg. 425. Damn. I think you're having GS, I guess. Yes, limit of x approaching a. Yes. You guys should be able to solve this one. You still get it to that thing now. It looks abnormal, but we solved something like this before. The graph. You are seeing it already. You are not seeing it. Oh, you didn't. You were not here when we did that one that required them. I can rub this part now. And I wanted us to get to limit at infinity. That's where you start seeing some weird stuff. Hmm? N, like, I don't understand your question. Okay, in that, for the denominator, what's n? N is n. So for your nanny, you want to use nanny in this case. Your n will also be n, but your a will be a. So you are not changing the formula. The formula will still look like this. And your answer will look like this for this denominator. I won't give you guys the answer. Should I solve it for you guys?
No.
Yes.
Yes, like the example.
See this denominator now. This guy is the same thing as this guy, Shebi. So that means I need to add something. So I first need to split it so that I can add it.
Don't worry.
You've seen it, have you? I'm coming. Muslim, Philip, what you get? It must look like this before you can use the formula. One over. What do you get? So what's the mommy? M. M minus 1. Times. Okay, nanny. N raised to power minus 1. Okay, let's solve it together. So now, just like that former question that we did, that had x minus 3. But in this case, this was they deal with letter x raised to power m minus a raised to power m over 1, should be times 1 over x raised to power n minus a raised to power n. I did not change the question, yes or no? I did not change the question, right? So now, what can I add here? They've given me the clue. The clue is in the question. X minus a. I need to add x minus a to both this guy and this guy. If I add this guy, if I add x minus a to the denominator here, it change to what? X raised to power m minus a raised to power m over x minus a. Should be multiply by x minus a over x raised to power n minus a raised to power n. Did I change the question? I did not change the question because this can still cancel out. So once it cancel out, I can multiply and get back to this guy. So now for me, I can use the formula. The formula is what? N a raised to power n minus 1. But in this case, what's your n? N is m. So this will be, and a in this case is what? A is a, right? Should be. So now, using the formula nanny, so this one will be n raised to power what? M multiplied by a raised to power m minus 1 times this one too. But now, like this one now, this place is meant to be at the meant to be at the denominator. So I need to use reciprocal whatever. So this one will not be multiplied. It will be divided by what? Divided by x raised to power n minus a raised to power n over x minus a. So now in this case, I can use the formula, and the formula is just this thing. So I'm not doing any what is m, what is n. This is the formula. I'm just writing whatever is here. So this guy using limit. Sorry, I forgot to add the limit. Limit of x approaching a. So now this will give me what? This will give me m raised to power a, m multiplied by a raised to power n minus 1 over n raised to power n minus 1. Do you get? So now then we can do some indices. This will be m over n multiplied by a raised to power m minus 1 minus n plus 1. You have seen it already. So this will be m over n raised to power m minus n. So this will be m over n multiplied by n minus n. From this place. You understand this part? For this one, we are just using the formula nanny. The formula is what? Let me write it here. Limit of x approaching a of what? X raised to power n minus a raised to power n over x minus a. This is the formula, and this is the scenario where you can use the formula nanny. So your question must look like this before you can just impute your values and get your answer. So now in this case, n is what? This is n, a, then n minus 1. This is the formula you will use. Your question must look like this. Must resemble this in format before I can use this formula. So now, this one now, it looks exactly like my question, maybe because of the limits that I are not seeing. Limit of x approaching a. This looks exactly like my question, but the difference here is m. So instead of n in this place, wherever I see n, I'm going to put m, because this one, the power here is m instead of n, just like the scenario that I'm meant to look at. So now, So now that means wherever I see, the formula is nanny abi. Wherever I see n, I'm going to put m. So this will be m, shebi. Then a is the same thing here. So I can write a. Then what is n in this case? Because the formula is n minus 1. But in this case, I'm not dealing with n, I'm dealing with what? M. So this will be n minus 1. This was how we got to this first part. You get? So now you understand this place, abi, how we got this you cancel out each other and we'll get back to the original question. So now, but the formula is meant to look like this. X minus a is meant to be at the denominator. See, x minus a, where is x minus a? Is at the denominator, but this one is at the top here. It's not meant to be it's meant to be at the bottom, but in this place is at the top. So now, how can I write this guy? When I have 8 over 64, I can write 8 over 64 as 1 divided by 8 over 64. And do you understand? It's just how to manipulate division and multiplication times 64 over 8. That's basically what I just did here. Do you understand? Do you all understand? If you don't understand, let me come again. I know, I'm not claiming. Which one? Do you know why I turned to this guy? And Gideon. Do you know why it's turning to this? Use the formula nanny, because this already resembles this scenario. This is a case study. But when your question looks like this, you can use NA raised to power. Yes, you can use it straight. So that's why, but in this case, there's no N. N is M. The only thing that just changed in the question is the letters that they used. The letters might be confusing. There's this question, but it's not very complex, but you need to see it before you can solve it. Okay, we have. Okay. Are you guys done writing?
Yes, sir.
Let's check. You're not done. Okay. Okay, let's check this question. Limit of x approaching a. X plus 2. 5/3 minus five. 5. Do you guys have an idea? Or you solve it?
His question is coming. The secret is the one you need here. Let's solve it.
Should we all solve it? Philip. Five over three. That's all.
I got 5/3 cube root of
5/3 cube root of
bracket a plus 2 square.
a plus.
Plus square.
Okay. All right. Let's look at it together. Okay. If I try what I tried before, that one that we splitted it, and if you add x plus 2, 5/3 minus a plus 2, 5/3 over 1 times 1 over x minus a. What can I add there that will make the question look like this? So if I add x plus 2 minus a plus 2, if I add it here minus, if I cancel this one out, do I still have my question? Yes or no?
Yes.
But what good does it do me? It will solve this guy, definitely. I'll be able to use the formula nanny to solve it. But what will happen to this guy? I'll be stuck. So using that formal method that we're using, you know what? We have to use You guys tried direct sub at all? You guys tried this sub? Like direct substitution? Never even take it. Okay, oh yeah. Okay. If I put A here, this will give me 0, 0 over 0. So that doesn't work. So now, basically what we need to do is we'll do some substitution tricks. Okay, let's say let y equal to x plus 2. Alright? And let b or let k equal to a plus 2. Right? So my question here now will be limit of x approaching, but now the limit will change because I've changed this guy to y and k. So it will be, the limit will be approaching y will be approaching k now because I've changed the whatever is inside this guy. You get? Because I've changed, the limit to change because of it. So now, instead of adding x plus 2 now, what will I be writing? I'll be having y raised to power what? 5 over 3 minus what? Minus k raised to power what? 5 over 3 over, but now, since I've changed everything from being x and a, I'm changing it to what? To y and k. So I need to equate, I need to get x and I need to get a. So I can get x and a from these two equations that I have. So now for me, if I make x the subject of formula, what will x be?
Y minus 2.
Y minus 2, great. For a, k minus 2. So now, if I put this guy in this place, wherever I see x, what am I going to put? Y minus 2. Minus k minus 2. If I open the bracket, what will I get? Y raised to power 5 over 3 minus k raised to power 5 over 3 over, if I open the bracket, I'm having y minus 2 minus k, right? Plus 2. Plus 2 minus 2 give me what? They'll cancel out. So that will be y minus k. Is it in the format? Yes or no? So if you use it, what do you get?
You get that value over k.
5 over 3. 5 over 3 what? What's the formula? Formula is what? Nanny. N minus 1. But in this case, what's my n? My n is what? 5 over 3. 5 over 3. What's a? A is k, Abby. A is k. So if I use the formula, I'll have what? 5 over 3. A, what's my a? My a is k into bracket. What's my n? 5 over 3, Abby. Minus 1. So this will now give me what? 5 over 3 into bracket k multiplied by what? 2. Yes, 2 over 3. Is this my answer? Thank you very much. This was what I did in one of my Mass 102 plus 2. Prince, do you understand? Do you understand, brother? So the trick here is, will you see the direct substitution? Once you see the substitution, when you get here, you solve your question already. But the only thing that can make you miss it is this k that will show your answer, and you'll be wrong. I guess that's all for. It's past 4:30, Abby. I wanted us to touch limit at infinity. We'll still get the trick. I know that's what you like. You know it, Abby.
94. 94. What is silent over x? No, I don't get it.
Silent over x is not 1.
Not like
What of the limit? You know the limit. Limit is approaching what? Is it 0 or infinity? Infinity. What of when is 0?
I don't know.
If it's infinity, it's zero.
There's one for infinity and there's one for zero.
If it's infinity to zero, it is zero, it is one. Okay, you pass.
When is zero is zero? When is infinity is zero? But sign
Sin
is
x over x is one.
Leave.
Yes, but sin x is equal to sin x over x is equal to 6 square x over.
sorry, it's one, it's one. Yes, when is zero? When is zero? When is this? When it is approaching zero? To give you one, Chibi.
No.
Limit of x approaching zero.
Yes, give me one.
Yes. When it is infinity.
Zero. Because x is infinity.
What of for cos? But it differs for cos. But in your slide, it will say it is. You say it is one and it is wrong. Abi? Yes, for cos. Cos is meant to be the odd one out. So that limit of x approaching zero for sin x over x is one. For tan
X over x is one.
is one. But for cos x is meant to be zero when it is approaching zero. When x is approaching zero. When your slide, sorry, in our slide, it said one. Yes, it is a standard limit, but there's a way to solve it too. I don't really know everything of it. I need to solve and write. So are we going to stop here? Wait. Because this past 4:30 already, 19 minutes. You know the French Army? So we'll probably touch limit at infinity next class. Then 3. We'll touch infinity method and trigonometric limit by next class. And should I give you guys an assignment?
It was assigned like 5.
Like 5, okay. So limit of x approaching 1 of cube root of x plus the 4th root of x plus the 5th root of x minus 3 over x minus 1. So you guys will know what to use, whether it is factorization, rationalization, or SRM. Then limit of x approaching 0, square cube root of 1 plus x squared minus 4th root, the 4th root of what? Of 1 minus 2x over x plus x squared. So these two guys should keep you busy a little bit. So you guys take these two questions. My time is 19 minutes over. You guys came. Thank you very much, everybody. So when we get to limit at infinity, you'll be seeing the kind of questions that they can ask in your exam. And you can see it, you can see this on your exam. But if you don't see this exactly, you might use this mainly for your questions around limits. He will not give you one that will just involve use SRM, standard result method. You might use like 3. You might use like 3 different methods to just to get to your answer. And after trying, when we get to those limit at infinity parts, you see some questions that once you use one method, the next thing you are going to use is direct sub to see if you get any other indeterminate value. So if you get, I have some things for you already. When you have 0 over 0, when you have infinity over infinity, when you have infinity over 0, use the L'Hopital's rule. When you try direct sub and it does not work, we'll talk about it when we start root at infinity. Thank you very much.
Let's see. Let's see. Wait, what's happening?
As all of us are